Currently, to be able to track bones in during like robotic assisted surgeries or computer assisted surgeries is you use either fluoroscopy, especially
Yep.
biplanar fluoroscopy,
Yep.
and obviously this introduces radiation.
Hmm.
And the other one is intercortical bone pins.
Yep.
These are considered the gold standard
Yeah.
of how to do. And intercortical bone pins is obviously you drill bone pins into the structures that you're
Yep.
tracking, and then you have, like I said, like a camera system like this that is localizing the markers that
Hmm.
on this bone pin. But the issue with this obviously is you have potential to damage or harm
Yeah.
the patient
Not
bones.
everyone wants to have bone pins drilled into them.
Yeah, exactly. Yeah.
Hello, welcome to Inside the Shoulder. I'm Kenneth Cutbush and I'm joined today by Ahmed Sewify. Ahmed has just completed a PhD in 3D ultrasound imaging of the shoulder, and so he's a fantastic guest to talk to today with a really interesting story and career path. Welcome, Ahmed.
Thank you. Thank you. It's a great opportunity. No, really. I've always wanted to have a chat with you like this
Yeah,
one day. So I think this is like a treasurable
yeah, I've been looking forward to it.
moment. Yeah, yeah. Thank you very much again.
So tell me, you were born in Egypt,
Yes.
first 4 years in Egypt?
Yeah. So uh, my dad is a doctor actually.
Uh-huh.
He's an ICU intensivist, and he moved around a lot, and
Hmm.
he took us with him as he kept moving
Hmm.
around. I think this is a good thing. It shaped my personality. I think I became more social, open-minded. Being able to talk to people from different cultural backgrounds and languages and stuff. But yeah, we first stayed in Egypt for 4 years, and then we moved to Saudi Arabia. I think for 2 years or so. Then came back to Egypt for 1 year, and then moved to UAE, Emirates. We lived in Abu Dhabi for 5 years, and then I left them at this point, and I went to Malaysia.
How old were you
Uh,
then?
I think I was like 16, maybe something like
Hmm.
that. Yeah. So then I started uni in Malaysia. And I think Malaysia was a good decision by my dad because he thought that it's a good transit to go first if I want to go to the Western world and stuff because it's not a big of a culture shock because I lived all my life like in like kind of Arab
Hmm.
what do you call it, countries and stuff.
Hmm.
And I think Malaysia is like also shares similar culture. They're also Muslim, like same religion and
Hmm.
everything. So he said, just go to Malaysia, start off your studies there. And I think in the last 2 years we had the option to like kind of transfer to a university that it's in collaboration with my university,
Hmm.
and QT was one of them.
All right.
So yeah, so I did my first 3 years there, and then my last 2 years I moved here on my bachelor's. But that was my entry point to Brisbane.
How old were you then?
Can't remember when I came here, but I probably around 19, maybe I'd say I came to Brisbane. Yeah.
On your own?
Yeah. The whole time I was on my own. Yeah, from Malaysia onwards.
Wow.
Yeah, yeah. I think
What
it
was
was
that like?
it was really hard at the start. I think, but I think I got used to it very quickly.
Because
Luck,
you wouldn't have known anyone.
not a single person. I moved here by myself. But
And where were your parents at the time?
so my parents were still back in UAE
Hmm.
and Emirates at that time, and yeah, like I said, luckily chatted with them a lot. I'm very close with my family. I think until today, I still talk at least to them once a day, or at least. And yeah, it wasn't easy, but I think I managed.
Yeah, right.
Luckily,
And you're a native Arabic speaker?
yes. So native Arabic speaker. I was fascinated by languages since I was young, so I took on English very seriously. And I think the way I learned it was mimicking songs. So like listening to,
Uh-huh.
let's say, like I don't know, Taylor Swift at that time. I actually used to like her a lot when I was a kid. And then being
I'm
able
going to ask you
to,
to sing a Taylor Swift song.
yeah, no way. I used to try to sing like her. And then I move up in difficulty. So like, I don't know, Eminem, for example, or something like that. And
Yeah,
yeah,
right. Cool.
that's how I learned English. And then I took on other languages like French and Japanese.
Yeah, I saw that.
Yeah, yeah, yeah. So I think my Japanese is, I'd say, my third language, and then fourth would be French. I
Hmm.
think. Yeah, yeah.
So your English was pretty good when you came to Australia.
Yeah, I think I didn't have any. Of course, I struggled a bit with the accent when I first arrived because I
Yeah.
was used to movies like they speak in American
Yeah.
and British accents, and then suddenly you have this Australian dialect. I'm like, I went to the lecture. I had no idea what he sang, but I think a week or two was enough for me to adapt.
Uh-huh.
Okay, yeah. So
So this was an engineering degree.
it was mechatronics. So I did robotics
Mm.
first in my bachelor's, and then I think as you can see in my CV, I went on crazy with internships
Yeah.
because
So tell me about that.
because I didn't know what I wanted to do. Like,
Yeah.
and mechatronics is
So what's an internship look like in engineering for everyone listening?
um, so when you graduate, normally the competition is really high. So I
Mhm.
think the best way you can secure a job, or the easiest way, I'd say, is you do an internship with a company for 3 months. And now because they have trained you for 3 months and they've wasted all this kind of resources and time on you, it's much easier for them to just hire you after the internship. That was the theory,
Yeah.
like of why you do an internship. So I at first I didn't know what I wanted to do because like I said, mechatronics is a massive umbrella. You studied like software, we studied mechanical engineering and electronics. I think it's even in the name, mecha, like mechanical, tronics, electronics
Yeah.
combined
Yeah.
together.
Right.
So I felt like I was capable of many fields that I can pursue, but I wasn't sure what I wanted to do. Um,
So who'd your first internship with?
Good question. I think my very first one was IT actually. It was an IT company called
Hmm.
NetAware. It was here in Spring Hill, and I think my friend got me the position. He's like, "Hey, we're looking for someone. Do you want me to kind of recommend you?" I was like, "Yeah, cool." And he recommended me, went for the interview, and I got the job. And I think I worked with them for 4 months, maybe.
Hmm.
After I finished my internship, they wanted me to continue. But one, I think I just felt it wasn't for me because I had a lot of skills that seemed wasted, like in like IT. I felt like also it was more of like a system administrator. So I didn't think that it required any of the skills that I already had, and I didn't honestly have the best fun. Like sometimes we would get calls to go on site, and they say the internet is not working, and you check the router, it's not even plugged in. So you just plug it in. I was like, that would be 100 something bucks. So I felt it wasn't the most satisfying job. But
Do you get paid for these jobs?
yes, so internships can be paid, can be unpaid, and
Right.
can be paid the other way around. You could pay to do an
Oh,
internship as
right.
well. Yeah, that's.
Did you
I
do one of
looked.
those?
I did one, yes, one in Melbourne.
Uh,
I was gonna get to that, but like I think after the IT, I did mechanical engineering,
yeah.
but I didn't enjoy working in like a warehouse and things like that. And like sometimes it would get hot, and I felt, and it's also very precise job because we use like drills and things like that. I just felt like it can mess up like very easily. So yeah, and then I went to electronics. Electronics is my least favorite like field in engineering because it's not easily like Googleable. Like if you're in software and you have a problem, you just copy paste the error online and you'll find like a Reddit kind of
Mhm.
post, or you could find like in a Stack Overflow kind of thread, someone telling you how to fix it. But in electronics, like if you don't know, like should I add a capacitor here? Should I add an inductor here? What do like? There's no principles like that are easy to follow. So that's why I didn't like kind of go that deep into electronics. But then, after that, I went to Melbourne. I worked for AOS. Was a company for working in jointly with the Australian Defence. So they were
Mhm.
like focused on weaponry and things like radar systems and what do you call UAV systems and things like that. And yeah, I think at that time this was like sorry no, before that I worked at like the warehouse was a paid internship. So I
Mhm.
was paying them, I think I paid 2K for the 3 months or something like that
Mhm.
to get the chance. And then, I didn't like the job like that. So I went to the AOS and I think I started to like that job a bit, but I didn't feel it was purposeful. Like weaponry and things, I just felt didn't align
Mhm.
with what I want to do. And then I moved to Biomedical. So Biomedical was a biomed company, and this was my intro, I think, to biomed. And I was really happy about it because it was the first time I can call my dad and have like conversations about job
Yeah. Right.
because like medicine and like
What was Bivacor?
Bivacor
Bivacor.
was it started off as a research facility.
Mhm.
I think now the CEO actually won
What
Australian
did
of
they
the
do?
Year. So they worked on an artificial heart. So they thought TAH. So they thought if the RVAD technology exists and the LVAD technology exists, why don't we kind of combine
What's
them?
RVAD and LVAD?
The right ventricle and the left ventricle systems. I
Yes.
think they like kind of you can replace I think half the heart. It was already an existing technology. They're like if we have both halves, can't we just like kind of align those two halves, combine those two halves, and have a TAH like a total artificial heart, and then we can like insert it into the human body. And it's not, it wasn't meant to be a permanent solution. It was meant to be a temporary solution until you find the donor, and then you can kind of like take out the heart and then transplant the new heart. So yeah, it was an amazing project. And I felt it was very purposeful. Like you're trying to solve a major problem. And yeah, it was an amazing internship. I think it was one of the best internships I've done. And this was like, okay, I think I found what I want. I want to continue with
Yeah, right.
with biomed. I think I go back to Egypt, and this was around COVID time, and even my project manager at that time, I think that he was made redundant or something like that. So he moved to a new company, and he called me. He's like, "Sorry, yeah, the position that we were offering." So after the internship, I have kind of informally received the position. He's like, "Sorry, it's no longer available. We are actually cutting down. Like we're trying to downsize and things like that." So it's like, "All right, cool." So I couldn't go back. So then I started thinking, like, "Oh, what should I do? I don't know." So I, my visa had already expired in Australia. It's like, what I should probably just prioritize going back to Australia. So I did a master's in engineering, and I came back here, QT again. All of my studies have been at QT. Such a loyals. I think they should build me should build me a statue. To be honest, I did a master's, and you know what is funny? Every time you study something, someone asks you, "Do you think you do a master's?" What? No way, impossible, man. I think I have time for that. I want to work. And then after that, I did a master's, and then it's like, "Do you think you're gonna do a PhD?" It's like, "Hell no, no way."
Yeah, yeah.
And then I ended up doing it. So I finished the masters. Same scenario. I think the masters was 1 year. It was still like kind of COVID time, I think, or something like that. And I was like, okay, what do I do now? Like, there's no positions, there's nothing. So I kept applying everywhere. And then I started also considering applying for a PhD. So I didn't. I never had the idea or the thought of actually going for a PhD until it's like it just popped up there. I was like, okay, there are PhDs there. I kept applying. And then luckily I did really well with my master's supervisor. His name was Professor Andrew Fielding. And he was kind enough to recommend me to other supervisors. So suddenly I felt like it was raining on me, like PhD opportunities from other professors. Like, hey, he recommended you for this X, Y, and Z positions. Would you like to come in? I was like, yeah, of course I'd love to come in. So yeah, I came in for an interview. There was like a chemical engineering position. That was a biomed, and I was like, I love biomed. I want to work on it. So this is where I met, I think, Davide, and
Yeah.
he explained to me his vision on ultrasound and how it's underexploited, and
Yeah.
he explained to me the whole physics behind it and everything. And he said, like, yeah, we think ultrasound has the capacity to do a lot more than what it currently does. And we think that the main limitation is the field of view. So if we can maximize the field of view of ultrasound, imagine having a real-time feed of an entire region, of an entire anatomy. Like how useful that would be to a surgeon, or to how to say it, post-operatively, like rehabilitation and stuff. Like for example, if you're able to monitor an athlete who has had an injury, and they're doing a particular exercise, if you're able to monitor if this displaces something or dislocates something, it's very valuable, or if it improves something. So that was his vision, and his vision was like, I think in simple terms, think of an ultrasound shirt that you can kind of wear, and it would be able to give you a view of everything that's inside the shoulder. Loved the project. I was like, of course, I'd love to continue with that. And that's how I started my PhD with him.
So how far did you get? Where did the PhD get to with the ultrasound?
I think the first project, because we thought this was a low-hanging fruit, was just let's prove it. Is this possible? Like, it's never been done before. Can we actually scan the shoulder from like all angles and obtain a three-dimensional encompassing view of the shoulder? And we focused on the shoulder, I think, for two reasons. One was the center, that I was going to get to that as well. that I think you and I were part of was a shoulder center, so we
Yeah.
had to kind of focus on the
Yeah.
shoulder. And the second thing is it's an anatomy that is easy to scan from multiple angles, just because
Yeah.
it's like the structure is open and you can scan it
Yeah.
from a lot of different angles. So that was the reason for selecting the shoulder. And we thought, okay, so yeah, what we will do is obviously, as you would do in a feasibility study, we will eliminate any kind of automation tools or any sources of error. We will use expert like sonography. We will use expert registration. We'll have like the best of the best and everything, and then just see if it's possible before we get into the everything that's technical and stuff. And yeah, we had two sonographers, I think Marion and Jacqueline, if you remember them, and they came in and they scanned the shoulder. And the way we did it was like, okay, so we asked the patient to stay in place, and they would go around and take like one volume at a time. And
So these are
put it
two.
together.
Just to everyone listening, these are 2D,
Three-dimensional
but
ultrasound.
initially 2D. Ultrasound's normally 2D. Isn't
Yeah,
it?
yeah,
It's the problem.
exactly.
You're trying to
Yes.
get it to
Yeah,
be
yeah,
3D,
exactly.
so you actually get like an MRI scan, a picture of the shoulder
So
that you could then cut up.
ultrasound had already kind of also made the advancement of from two-dimensional ultrasound probes, which would just give you a cross-sectional
Slice.
view,
Yeah.
slice, into kind of a cube or like a volume,
Yeah.
an ultrasound volume,
Yeah.
and it would be multiple slices kind of combined together. So we used the new three-dimensional ultrasound probes, but they would still have almost the same field of view as the 2D probes.
Yeah.
Because yes, you've increased the field of view, but it's still very small.
Yeah.
You still can't see much. So we're like, okay, if we use the 3D volumes and combine them, can we get an encompassing 3D ultrasound view? I think that was
Were you able to do that?
yes, exactly. So we
Yeah.
did it maybe 3 times or so. Yeah, I think it's like different ways and trying out experiment. So I think honestly, I'll be honest, most of the conception came from Davide. I think he had that vision of
he's
how
very
the
clever.
project should be. He's extremely clever. And we were like, okay, that's a brilliant idea. And I think he immediately said that I don't think any of the current automation tools can pull this off. If we want to have an automatic way to do it, we're going to have to use AI. So you're going to have to use like a deep learning method or something that is able to recognize the patterns and do it on its own in real time. Also, computational methods are very computationally expensive. So, and how can you do it in real time? Like, it's not going to be possible. So he said, first, let's prove it. So we proved it. We did that, like I said, manually, and then go back to the lab, look at the anatomy, and use your kind of clinical knowledge to put all the volumes together. And we had it. And then we had the two sonographers. We had one blinded to the entire process that she was not involved in the process, and then another that was involved in the process, assess all the structures. And I think we came to you and Ashish for that. And I think we thought it was like, okay, first, before we start assessing structures, let's talk to actual shoulder surgeons and see what they would be interested in. So, like in seeing in an ultrasound scan of that sort. I think specifically you helped us a lot. I think you also gave us the acromio-humeral distance, I think, as well.
Yeah.
You suggested
right.
that. You said that maybe this is hard to see in a two-dimensional ultrasound scan. So if you're able to see that in a 3D scan, that would be very valuable.
Yeah.
So yeah, we did that and we measured all the structures. We had the sonographers assess the demonstration of how it's looking. And we were able to not only prove that it's possible, we were able to prove that it's clinically useful. And when I say clinically useful is because we were able to measure structures that you cannot see in a single ultrasound volume or image. So when you combine those images, let's say of the humeral head, for example, or for the clavicle or something, you would able to measure the entire kind of like distances and structure and stuff like that. And so that I think we thought this is extremely valuable. So that was the first project. And then second project was like, all right, let's try to do this again in an automatic way. And we brought a robot arm, attached the ultrasound probe to it, and then we started scanning the shoulder again and trying to reconstruct it using the reading of the tracking system. And then we pulled up other current automation tools that are out there, like automatic registration algorithms and segmentation and things like that. And then we had the expert supervisors that would supervise the process, so you can manually adjust anything that goes wrong. And we reconstructed the whole shoulder. And the idea for that was we wanted to simplify the registration process because registering the images, like putting them together, takes a lot of time. I think it
Yeah,
took
right.
us maybe 3 months of 3 different operators to put together one shoulder for the manually. It was such tedious work.
People will be waiting a long
It
time for that
was,
report to come through.
it was a very tedious process. So like the idea that we had there was if we want to train an algorithm, because I don't know if everyone knows what like how deep learning methods work is, you need to show the network a lot of solved examples for
Yeah.
the network to learn how to do it. So that means we have to solve the problem multiple times. So we obviously, if it's going to take, let's say, I don't know, 3 months from 3 different operators, and some of them are sonographers, let alone, so it's not going to be possible to collect enough data to train an algorithm. So like, let's try to simplify the process, create like a pipeline that people can use to collect the data so that we can train an algorithm. So we try to at least semi-automate it because we knew automatic methods are not enough. And yeah, it was a lot faster. I think it was about, from memory, maybe 40 hours or so per trial, which was like amazing. And yeah, we registered together. How many shoulders? I think off the top of my head, 12 or 14 shoulders, different shoulders. And I think that was the most valuable contribution, I'd say, from my end. And I kind of gave that data to the center and to the faculty that can, like, new people that can come in can use this data as well. And I think now I'm trying to look to use this data to train the algorithm now, because I think that's where we left it off. We collected the data, we proved that we can do it automatically, we proved that we could do it manually as well. But now the next step is, can we do it in real time using deep learning? Like so. And then on another side, so I was doing all this during my PhD, and then obviously to finish a PhD, you have to complete 3 projects. They don't need to be published, but you are heavily encouraged by everyone around you. Like, you don't have to, but please do it.
Yeah. Yeah.
And on the other side, I have this philosophy. I think my dad always used to tell me this: never say no to opportunities. It's like, say yes and then figure it out later, kind of thing. So I think the center came up with this idea. Maybe you were involved in the talks, I'm not sure. That let's bring together, because we had in the center, we had a lot of different programs, and each program would focus on something different. So you'd have like I don't know, robotics program, you'd have a biomechanics program, you'd have, and so on. So like, how about we make an interdisciplinary kind of project that would combine people from different disciplines, since we have them and they all focus on the shoulder, and we bring them together for that project. So I think Saulo came in and he asked me to come into a meeting. He asked, I think, Max Levi, if you remember him, also from biomechanics, Dermot at that time. And he said, "Hey guys, this is my current project. I'm thinking about it. How about, can we, if we are able to track the position of an ultrasound probe, can we localize the bones? Can we track the internal bones? Because if you think about it, you know the position of the probe because you're tracking it, and the probe can see inside the shoulder, so it knows where the bones are. So theoretically, you should be able to track where the bones are. And this was his idea, and we thought this is an amazing idea. So like, why don't we go through with it? So and it fit perfectly into my PhD, because we will have to be able to track the structures at some point. Like the first structure will be reconstruction, and then you would have to start doing bone localization and bone tracking. So I was like, all right, I'll do it. Yeah, let's do it. So I was doing it in parallel, and and then I think at that time, Dermot, I think, moved from our institute. So then there was no longer a lead, because we were granted a grant on the project as well. And then so I went into Sala. I was like, can I lead this project and make it part of my PhD? And he said, yeah, for sure. And it was still at kind of early stages. We hadn't like finalized everything yet. But we had received the grant, and we had started the data collection of like the cadavers and everything. And yeah, I managed to luckily get the lead position, and we completed the entire project, and it was very successful. I think it was one of the biggest projects I have made, just because also I think we borrowed some of your fellows who came in, and they drilled in some bone pins and stuff, and they attached the bone frames to the scapula and the humerus, and we had like a camera system, like kind of like this with Vicon system, and we were tracking using like the intercortical bone pins, the position of the shoulder, and massive project. Like we had like literally expert in everything. So, and I think this gave me the ideas like, yeah, why would you do research alone? Yes, when you do things alone, don't get me wrong, you learn a lot because you have to learn every single part of the research to do it. But I think, as they say, together you go further. But when
Correct.
you
Yeah.
have an expert in each field, and then you bring them all together and you create a project, the project just goes like way faster, and then I think way easier. And then obviously you learn from them on the job. As the lead, you have to know what everyone else is doing and how everything is coming together, because you ultimately have to draft and analyze the data and things like that. So yeah, it was an amazing experience, I think, and learned a lot.
So that third project,
Mhm.
tell me about it again. What did you end up being able to do?
To give a brief kind of idea of what the concept of the project
Yeah.
is, currently to be able to track bones in during like robotic assisted surgeries or computer assisted surgeries is you use either fluoroscopy, especially
Yep.
biplanar fluoroscopy,
Yep.
and obviously this introduces radiation.
Mm-hmm.
And the other one is intercortical bone pins.
Yep.
These are considered the gold standard
Yeah.
of how to do. And intercortical bone pins is obviously you drill bone pins into the structures that you're
Yeah.
tracking. And then you have, like I said, like a camera system like this that is localizing the markers that on this bone pin. But the issue with this obviously is you have potential to damage or harm
Yeah.
the patient
Not
bones.
everyone must have bone pins drilled into them.
Yeah, exactly. Yeah. So then we thought, and the alternative now people proposed was something called skin mounted markers.
Yeah.
And you would put the markers that you have drilled in on top of the skin, and you would be able to kind of try to track it again. But then you rely on the assumption that there's a linear relationship between the skin and the bone, which is, we all know that this assumption is false.
Really. Yeah.
So they have much less tracking accuracies
Uh-huh.
compared to the skin mounted markers in fluoroscopy. So then there came this new movement, which is very new area of research, was why don't we use ultrasound? Because ultrasound can see inside the bone. We don't need to make that assumption anymore. So yeah, like I said, you track the ultrasound probe, you put in the markers that you put on the skin on top of the ultrasound probe, and now you let the ultrasound probe see into the bone. Sorry, see into the skin, and you're able to localize the bone. So that was pretty much the project. So we tried it on a cadaver. We compared it against intercortical bone pins because we knew this was the gold standard or whatever. And yeah, it worked out amazingly. Like
Yeah, right.
we did it in simulation, and we did it in like an experimental cadaveric study. Yeah, it was an amazing project.
So these are ultrasound probes on the skin?
Yes, exactly. Yeah. So
Okay.
yeah, you
All right.
localize.
So where to with that work from the PhD?
So I think towards the vision that we talked about is we would love to have a real time comprehensive view of the shoulder in an ultrasound modality.
Yeah.
I think if we can manage that, I think it would be groundbreaking. I don't think it would replace MRI or
No, but
CT,
add to it.
but it would open like kind of the doors to new applications
Yeah,
and,
right.
and such. So yeah, so I think now the next step for me would definitely be one is from the reconstruction side, train train the network on the data that we've collected, and from the tracking side is during our experiment in the cadaver we had. Again, we did the same thing as we did in my first study with the reconstruction. We assume that the patient is not moving. So again, we have the sonographer scan and then move and then scan a different part and then move again. But then when we looked at the images, we saw that there was patient motion during that. And also now we said we're tracking, but it's called static kind of localization or static trials, because you move it and then you stop it and then you scan all around the shoulder and then you move it and then you scan, because you had one probe. So I think to move from there, we ideally would have multiple probes. So you would be able to do it in real time. You wouldn't have to kind of do the static trials anymore.
So you finished that in August?
Yes.
So where to now for Ahmed?
So I think I was actually just chatting with your team about this. I think after I finished, as soon as I submitted my final seminar, and in my opinion, normally if you get your final seminar and they say minor revision, no to minor revisions. You pretty much finished your PhD. Now from now on, it's like the same process from acceptance to publishing a paper.
Yep.
So it's all like edits and formatting and things like that. So as soon as I did my final seminar, I immediately did a postdoc with the center. And my job was to wrap up some of the studies that were left by other PhD students or other
Yep.
postdocs before they left. And after my contract ended, which was I think 9 months, I found another position, robotics. So I went back to robotics. And I think, unfortunately, in as a postdoc, you don't normally get the choice
Yep.
to into what you want to do. Like I said, you never say no to opportunities. Every opportunity pushes you up the ladder or gives you experience and such. So I went back to robotics and I worked there. It was a 6 month contract, and now it was coming to an end. So then
Now, what was that in?
it was actually it was a poultry processor.
That's right.
It's
Yeah.
completely different. Absolutely has nothing to do with the PhD.
So, what does robotics have to do with poultry processing?
So poultry processing actually has advanced, not just poultry, meat processing, but has advanced significantly. And everything is pretty much done, like using like deboning, like you take the bones off out of the chicken, marinating. Everything is done by robots at the moment. But then at points where, let's say this is one pipeline that is doing something, and after the line ends,
Yep.
there's a bunch of workers that would kind of carry the chicken and then they put it into the new pipeline. And then so it's that transition that it is always manual. So that you'd have to hire a lot of people then. So you see a lot of people's jobs is to pretty much carry the chicken and then just hang it, and they would do that at extremely fast speeds because they have to keep up with the lines. And yeah, my job was to kind of find ways to replace the manual task with an automatic task. So
Yeah, right.
I think that was
How'd you go?
We're going, I think, pretty well actually. Yeah, we're just showing some ideas, writing some feasibility reports, and then we were showing. I think it's the choice of the processor how they want to move forward. So yeah, that's
Right.
So yeah, after that, I received a. Okay, so I think this was a story. Max Lawai, I think he's in our center. He sent me a link of an Oxford position advertising a project that is extremely similar to the one that I was working on. And I don't know, I was like, well, Oxford.
The ultrasound one.
Yes,
All right.
extremely similar. So I think this shows how like hot the topic is. And they were looking for a research assistant. And they I was like, okay, you know what? Maybe I should apply for it. But if you think about it, like, okay, it's Oxford and stuff. It's like, oh, like you're not used to this. So I applied for the position.
Yep.
And I think I immediately messaged the professor who advertised the position on LinkedIn, and I said, look, this is extremely similar to what I did. Here's my thesis. I think I'm a good fit and so. So I go for the interview, and he messaged me back saying HR will be in touch.
Yep.
So just like that. And I think literally 2-3 days later, I get an email from HR saying, hi, you've been shortlisted. I think one out of like the 5 potential candidates or whatever for the position. So can you please log on and on that day, and we'll have a Teams meeting. And I did not expect it to be this brutal. I was ready to do pretty much this, like talk about myself and my experience. But I think you only have very little time. You have like 10 minutes or something. And you have to very quickly tell them what you've done and then focus mainly on your PhD. And I think the thing that I learned from this interview is like they say, don't go wider, go deeper. So instead of talking about all the projects that you've done in your PhD, pick one project and then you just discuss it for the all 10 years.
Why do you say it was a brutal experience?
I think it's because I didn't expect it to be very testing. Like I thought it would be just like a chat and stuff. And then so they asked a lot of questions on the PhD, and I think this is easy. It's my work. I can talk about it. But then the last part was kind of like a trivia, pretty much on robotics and biomechanics. It's like when a robot moves from point A to point B. What as well. I think I knew a lot of this stuff, but it's just when you put on the spot, it's not very easy. And especially I didn't expect it to, so I didn't prepare for these type of questions. So yeah, unfortunately, I got an email on the same day saying sorry. We decided to go with another candidate. But then actually a professor from that team, so actually on the panel, you had, because it was a multidisciplinary project, had a biomechanics expert, and you had a robotics expert who was the lead,
Yeah.
and you had an HR representative. That was the panel.
Mm-hmm.
So 2 or 3 months later, I get an email, I think, from the HR, I think was a representative, and saying, "Hi, we actually have a role that, sorry, not the HR, the biomechanics expert, saying, hi, I actually have a role which I think kind of suits you, your skills a lot more. But I have moved to Denmark I moved from Oxford to Denmark. Would you be interested in applying for this
All right.
position?"
Yeah.
I was like, yeah, of course. He's like, cool. All right. So he sends me the link of the position. I apply to the position, go through the whole process. This time I learn, I think, from my mistakes in the interview. I think I did the interview a little better. And I think they granted me the position. So I've been recruited. I think I'm going in 2 months.
Oh, really? To Denmark?
To Denmark, pretty much. Yeah, yes. It's also
So it's going to be another language then?
another language added to the list.
Actually, you brought something in for us to show us.
Exactly. Yes.
Can you hold this up?
Of course, that is the T-shirt of the Joint Biomechanics Center. That this is where I met actually Ken.
Yeah.
And yes, amazing center. I must say.
Yeah. So as part of an Australian Research Council grant, and
yes. So I think that this was already granted, I think, to Davide at that time, I think.
Yeah.
And Davide was part of the Maria and Davide, I think, were part of they're my supervisors. And yeah, when I enrolled into their PhD, I think I automatically became part of the center, and my office was part of like the center as well.
Yeah.
And we would have those regular catch-up meetings, and you would see all of those interdisciplinary. Everyone is working on the shoulder, which I thought was very interesting, but from different angles. Like, you have the kind of the biological part of the shoulder, and then you have the biomechanics part, and you have the completely robotics part of the shoulder. So it was really interesting to kind of hear about all this work, and you get inspiration from people. And like I said, if you're facing a problem, I can literally just message one of my mates and be like, okay, hey, you're the expert on robots, right? Can we have a chat? I'm like, yeah, cool. Hey, you're the expert on ultrasound calibration. Can we absolutely amazing. Like it was, yeah, like I said, I can't take it for granted. And like work moved really fast, and you're able to do like things that are groundbreaking like this. So I thought even if I moved to Denmark, I thought like I would love to continue collaborating with like people such as yourself and people here from the center and stuff, especially if we're working on the shoulder, to continue working on that anatomy. So yeah.
Fantastic.
Thank you so much.
Thanks, Ahmed.
No, thank you very much.
Thank you for listening to Inside the Shoulder. I'm Kenneth Cutbush, and I've been with Ahmed Sewify today. We've had a really good chat, and I hope that people have thought a little bit about how hard it is for these guys to do this process and get to a PhD, and how much of their life it really consumes them.
It's extremely tough. Yeah.
Thanks. Thanks, Ahmed.
Thank you very much. Thank you. Thank you.
If you enjoyed this episode, please like, share, and subscribe on your favorite podcast platform. Thank you for listening.